how ants use acid in amazing ways to protect our forests. Wildlife photographer Ringo Arndt's fascination with ants began when he was a child. While exploring a forest in Germany, he encountered a large ant mound covered in spruce needles. The pungent smell of vinegar-like acid warned him to approach with caution, but it also left a lasting impression on him. As an adult, Arndt became a seasoned wildlife photographer, traveling the world to capture the essence of animals, but the mystery of the ants and their massive mounds continued to intrigue him. When he returned to Germany with his wife, he rekindled his curiosity about these ants and their remarkable structures. Outfitted with a high-resolution camera, Arndt set out to learn more about the ants responsible for the enormous mounds. The ants were identified as redwood ants, a species within the formica genus, renowned for their role as keystone species in Eurasian temperate and boreal forests. Keystone species, like elephants and sharks, are critical to their ecosystems because their actions shape the environment around them. The decline in redwood ants, due to factors like logging, wildfires, urbanization, and climate change, has led to their legal protection in many countries. Arndt's 2-year photo project revealed the incredible complexity of these ants and the many relationships they maintain with other species in their environment. The mounds, which can support anywhere from 30,000 to 16 million ants, are built both above and below ground, utilizing materials like tree needles, bark, and twigs. These structures are the largest above-ground nests created by any ant species. Arndt collaborated with entomologist Bernhard Seifert and zoologist Jürgen Tautz to better understand the role of these ants in their forest ecosystems. One of the most surprising aspects of redwood ants is their ability to produce formic acid, a substance they use both as a weapon and a defense mechanism. They generate this acid in a venom gland at the rear of their abdomen and use it to fight bacteria and fungi, ensuring the health of their nests. The ants also gather tree resin, which has antimicrobial properties, and mix it with formic acid to create a more potent agent that helps protect their home. Additionally, the acid is used to fight off pests such as wood-boring beetles, a destructive species that weakens trees. The ants' formic acid also allows them to maintain healthy aphid populations, which provide them with honeydew, a critical food source. Arndt's research also uncovered how larger animals benefit from the ants' unique abilities. For instance, Eurasian jays have been observed landing on ant mounds and allowing the ants to crawl on them. In return for this uninvited spray treatment, the ants attack parasites such as mites and lice that infest the birds. The ants' formic acid is powerful enough to disperse or end these parasites, helping the birds maintain their health. This symbiotic relationship is an example of how these ants contribute to the well-being of various species. Beyond these direct interactions, Arndt discovered that other creatures, such as mites, spiders, and flies, also coexist with the ants in their nests. These species, which have adapted to the ants' environment, can often go undetected due to the scent of the nest. For example, when leaf beetles lay their eggs near an ant mound, the ants inadvertently transport the eggs into their nests, where the larvae are sheltered and nurtured. As the larvae grow, they take on the scent of the nest, which helps them avoid detection by the ants. Studies have shown that over a dozen different species can live within a single ant mound, forming a unique, multi-species community. Through his photography, Arndt has brought attention to the remarkable role of these ants in maintaining forest health. His images highlight how these often overlooked creatures influence their environment in subtle but powerful ways. Despite the challenges of working with a protected species, Arndt has managed to capture the complexity of the ants' behavior, sometimes even finding them hitching a ride back with him. The ants' role in preserving the forest ecosystem is invaluable, and Arndt's project sheds light on how these tiny creatures work together to shape the natural world around them. In the end, the collective power of ants plays a vital role in sustaining the health of the forests they inhabit. Their remarkable ability to produce antimicrobial substances helps protect their nests and the surrounding environment from harmful bacteria and fungi. Additionally, their efforts in safeguarding trees by fighting off destructive pests and maintaining the balance of local ecosystems showcase the critical role even the smallest species have in preserving the integrity of our planet's forests. These creatures, though small and easily overlooked, are essential to the delicate balance of nature, making a profound difference in maintaining the ecosystem's overall health and resilience. Their unseen efforts ensure that the natural world remains in harmony, emphasizing how interconnected and vital every species is in sustaining life on Earth.